Okay, 7.2. I've decided to do this one on my little graph paper. Nobody's yet expressed a definite opinion about whether they prefer the PowerPoints to me writing. I am interested in your opinion, though, so let me know what you think. Today we're talking about exponential decay functions. So the first thing we're going to talk about is how exponential decay is different from exponential growth. Then we're going to talk about how you can tell something's a decay function rather than a growth function from the equation. And then the third thing we're going to do is graph a few examples. That's really the entire lesson. So, right, question number 1, how is decay different from growth? In 8.7.1, we were graphing exponential growth functions. They look like this. Y equals 2 to the x is a good example. You can see as you move to the right, the graph is growing. For an exponential decay function, as you move to the right, the graph is shrinking. Now this is because every time x goes up by 1, you're multiplying by the base again. So exponential decay happens when your base is less than 1. Anything to the 0 power is 1. So this graph has 0, 1, just like the other one. But if I move one space to the right and stick in 1 for x, I get 1/2 to the first power, which is 1/2 rather than 2. It's smaller. And every time I multiply by 1/2, like here, 2, 1/2 squared is 1/4, it's getting smaller rather than bigger. As I move to the left, if I stick in negative exponents, that does the reciprocal, and the 1/2 becomes a 2. So negative 1 goes through 2. So over here on the left, it's getting bigger rather than smaller. So it's got the same basic shape as a growth function, but it's headed toward 0 rather than heading toward infinity. The horizontal asymptote's over here on the left, rather than, it's over here on the right rather than the left, as the growth function has. So same basic shape, same basic procedure for graphing, just watch out for the fractions. So that's how they're different, and I already kind of said what makes it a decay function is the base is less than 1. There is an exception we're going to talk about in 7.3, but for today, you can just worry about looking at the base. If the base is bigger than 1, it's growth. If the base is less than 1, it's decay. Be careful of fractions like 4/3. If you're not being careful, you'll look at this, see it's a fraction, and assume that it's decay. But 4/3 is bigger than 1. So this if this were your base, it would represent a growth function, not a decay function. That would be growth. All right, let's get into some graphing so you can see how these work. I already graphed 1/2 to the x. So let me graph y equals 1/3 to the x. Now, just like in 7.1, because there is no k, the horizontal asymptote is not going to move up or down, and my horizontal asymptote will be here at y equals 0. This is a decay function, which means I'm going to be approaching my asymptote here on the right rather than over here on the left. It's going to be coming down towards 0 as we move from left to right. The rest is just making a table of values. If you try sticking in positive numbers, you'll get fractions, which is fine. 1 will be 1/3. 1/3, just graph 1/3 as best you can. Don't worry too much about it. Sticking in 0 gives us 1, just like always. Now the negative ones become easier to stick in, because if I stick in -1, it turns that upside down, and I get 3. And -2 would be 3 squared, which is 9, which is a bit high for this graph, and I already have 3 points, so I'm just going to draw it. Coming up from my asymptote, 3 points, nice and steep. And there's my exponential growth function. I label my asymptote. I'm going to label a couple of points, 1 1/3, 0 1, -1 3, and hey, there it is. The domain and range, your book is going to ask you for them, as you'll need them for the test as well. Just like for growth functions, exponential decay always has a domain of all real numbers. And in this one, for the range, the horizontal asymptote is at 0, which means the y's I need are all the ones that are bigger than 0. Next, y equals 3 times 1/5 to the x. Be careful to not get confused by the order of operations. The 1/5 to the x has to happen first, then we're going to multiply by 3. So don't raise 3 to the x power, that would be a mistake. So we still have no k, which means the horizontal asymptote here is still at 0. Need a few points. So when x is 0, I'm going to get 1. 1/5 to the 0 is 1, but I have to multiply by 3, so it's going to go through 0, 3 instead of 0, 1. If I stick in 1 for x, I get 1/5 to the first power, which is 1/5 times 3 is 3/5. 3/5 is about here, more than halfway. Stick in -1, that becomes 5. 3 times 5 is 15 already. That's really high. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's way up here, high enough that probably not going to graph it. I have my 2 points that I need though, so I'm going to come up off my asymptote through my points, head up really steep so it looks like I'm heading toward that point way up here that I'm not going to connect to. And that'll do. 1 3/5. 1 3/5 and 0 3 are my points. Label my horizontal asymptote. You can't even read that. 1 3/5. Label my horizontal asymptote and my 2 points. Let's do one with a transformation in it. Y equals, for example, 2 to the 1/3, 2 times 1/3 to the x minus 2 power plus 1. Here you can see h is -2, k is positive 1, which means the horizontal asymptote has moved up. So instead of being at 0, my horizontal asymptote is at positive 1. That's where k is. Horizontal asymptote at y equals 1. I need a few points. Easiest one to stick in is going to make my exponent 0. So I'm going to start with 2, because 2 minus 2 is 0. 2 minus 2 is 0. 1/3 to the 0 power is 1. So I have 2 plus 1, which is 3. 1, 2, 1, 2, 3. 2, 3. I need at least one other point. It's going to be way easier to try to make this exponent -1 so that this becomes a 3. Well, I guess I can do 2. You know what? It's fine. I'll stick in 3 first, get the fraction. Then I'll do the one that you probably want to do. 3 minus 2 is 1. That's 2 times 1/3, which is just 2/3. So this is just 1 and 2/3, which isn't really that bad to graph. So when I stick in 3, I get 1 and 2/3, about right there. If anybody cares, that's 5/3. 3 5/3. Probably easier to stick in 1 though. That gives me -1, which makes 1/3 to the -1, turns it upside down, it becomes 3. 2 times 3 is 6. 6 plus 1 is 7. So 1, 3, 4, 5, 6, 7. There it is. And there's my exponential graph. Asymptote, couple points, good to go. The domain, I forgot to do domain for the last one. I'll do that in a second. The domain here, x, all real numbers for the domain. And the range, y has to be bigger than 1 because the asymptote's up here at 1. This one was just like the one before it. Domain was all real numbers. And the range, y is greater than 0. Because the horizontal asymptote there at 0. Those are my examples. Most of our problems for 7.2 are graphing. You can see the assignment posted online. Let me know if you have any questions, and have fun graphing.